Hi, hello, welcome back to our channel Chemistry with RK. Firstly, I would like to thank each and everyone, those who are contributing your subscriptions, like, shares and comments. So, I feel very happy when I see, this type of support from all of you. So, thank you so much for that. And then within one day, almost it is reaching from 400 to 500. Thank you so much for your support and love. So, at the same time, I'm going to give, all the concepts in an easier way of understanding. And then I'll make sure that, I'll give you all sorts of tricks and techniques to solve all the competitive exam questions as far as IIT and NEET is concerned. Thank you so much for that. And then please, I request, if you're new to the channel, so please do subscribe, and then don't forget to click on the bell icon for regular updates. Yeah, let's move on to N factor. So what exactly N factor? Actually, N factor is defined differently for different compounds. So for acids, we define N factor as basicity. For bases, we define N factor as acidity. For salts, we define N factor as total charge. So what exactly these terms? Let us see. So if you talk about for acids, the N factor is generally termed as basicity. And now the basicity is called as the number of H plus ions produced in the dissociation of one molecule of an acid. So what does it mean, sir? So if you take one particular molecule of an acid, so how many such H plus ions are produced in the dissociation? That number defines the N factor. Hope you understood. So I'm just repeating the statement. So the number of H plus ions produced in the dissociation of one molecule of an acid is called as N factor for acids, which is basicity. And now let us just observe the examples here. So if you see, all these are the acids and their dissociations and their N factors. If you see HCl, in the dissociation it gives generally one H plus ion, so the N factor is 1. In HBr, it gives one H plus ion in the dissociation, so N factor is 1. And then HI, HNO3, HNO2, perchloric acid, chloric acid. So in all these compounds, if you can see, one hydrogen ion is being produced. So for all of them, the N factor is going to be 1. Hope it is clear. So let me give some more examples. You please try to take the screenshot. Okay, so here I have given few more examples. So just let us understand their dissociation, and then I left this particular N factor blank for you guys. So you please try to have a guess about their N factors. Okay, so that is chlorous acid. Okay, so this is chlorous acid. If you see, how many H plus ions are produced? 1. So I hope you know what is the N factor. It is going to be 1. And this is hypochlorous acid, and then again we have only one particular H plus ion, so its N factor is going to be 1. And then when we move to, that is formic acid, so here even though we have two hydrogens, but only one H plus ion is being produced. So what is the general N factor? So it is 1. And then why it is like that, sir? So since we have two hydrogens, only one H plus ion is being produced. Why that particular case is like that? Okay, it's not only about that case. So wherever we have this type of cases, actually if you try to draw the diagram of formic acid is going to be HCOOH. Yeah, this is the structure of formic acid. And now if you can see here, the hydrogen which is attached to oxygen can undergo dissociation easily compared to the hydrogen which is not attached to the oxygen. Okay, so why is like that, sir? So if you observe, the electronegativity of oxygen is very high. So oxygen would tend to pull the hydrogen's electron. So but whereas if you see, the carbon and hydrogen's electronegativity difference is very small, very less. So this particular bond is comparably strong compared to OH bond. So that's why not only in this case, in all the cases where we have the hydrogens attached to oxygens can easily undergo dissociation. So that we have to consider the number of H plus ions which are the number of hydrogens which are attached to oxygen can able to undergo dissociation easily, and those particular H plus ions are only we need to consider in the calculation of N factor. Hope it is clear. So that's why the N factor for formic acid is going to be 1. Similarly, if you see, the next one is acetic acid. Here you can see 4 hydrogens, but how many H plus ions are being produced? Only 1. Why? Because the same type of case here also. If you can see carefully, the hydrogens, 3 hydrogens will be attached to carbon, and only the one hydrogen will be attached to the oxygen. So that's why this particular hydrogen can only undergo dissociation easily. For that reason, the N factor is going to be 1. Hope it is clear. Please drop out your doubts in the comment section. I'll be replying to all your comments. Okay. Next, if we move to H2SO3 sulfurous acid, so it is going to give us 2 H plus ions, and then since because of we are getting 2 H plus ions, the N factor is going to be 2. Hope it is clear. Okay. And then next, let me just draw the structure of this so that you will understand. The group number of sulfur is 60A. So the maximum number of bonds it can form are total 6. Okay. So yes, actually this is what. And now H2SO3. So that's it. If you can observe H2SO3, so you are going to get, we are going to have H2SO3. Yeah. So this is the structure of sulfurous acid. So that's why both the hydrogens are attached to oxygen, so they both can undergo dissociation. Similarly, if we move to sulfuric acid, so we have got 2 H plus ions. Again, we are going to get a N factor of 2. And now what is the difference, sir? Here also the structure for sulfuric acid is this, H2SO4. And now for that reason, 2 hydrogens are attached to oxygen, so that will those hydrogens will undergo dissociation. And the next oxalic acid, so again it is going to produce 2 H plus ions, so the N factor is going to be 2. Hope it is clear. Let me come up with some more examples on these acids only. You please try to take the screenshot. Yeah, here are the 3 examples, that is H3PO4 phosphoric acid, H3PO3 phosphorus acid, H3PO2 hypophosphorus acid. And let us now just think about the dissociations and N factors for these 3 compounds. If you look at this H3PO4, we are going to get 3 H plus ions and then PO4 minus 3, that is phosphate ion. Since we have got 3 H plus ions, the N factor is going to be 3. Yes, why, or like if I ask you why the 3 hydrogens have undergone that dissociation process, because we can get a thought that okay, so there could be 3 hydrogens directly attached to oxygens. Okay, yes. And now if you try to draw the structure, so phosphorus group number is 50A, the maximum number of bonds we can expect are 5. And now this is the proper structure. So if you can observe here, so H3PO4 structure is this. Yes. And now if you can see 3 hydrogens, all the 3 hydrogens attached to the oxygens, yes, all of them can able to undergo dissociation. Now when it comes to H3PO3, so out of these 3 hydrogens, only 2 hydrogens are going to undergo the dissociation, while the 1 hydrogen will remain with phosphorus. And now what is the N factor? 2. And now why is this particular compound has N factor 2? That is obviously, so it is going to give us, one of the hydrogen will be directly attached to the oxygen. So for that reason, this is not going to undergo dissociation, while only these 2 will undergo dissociation. Clear? And then next, H3PO2 hypophosphorus, out of those 3 hydrogens, only 2 hydrogens are going to undergo dissociation. It is going to give us H2PO2 minus. So the N factor is going to be only 1, which means that in the structure of hypophosphorus acid, only 1 hydrogen is directly attached to oxygen. Hence, that can only able to undergo dissociation. Hope it is clear. So these are the few examples which we can able to discuss in the case of acids N factor. Hope it is clear. You please try to take the screenshot, and then next we will move to the N factor for bases. Okay. Next, let's move to the N factor for bases. So generally for bases, the N factor we take it as acidity, and now it is quite opposite to basicity. So that is the number of OH minus ions produced in the dissociation of one molecule of a base is nothing but acidity. And now, so if you can see here, I have given few examples. So that is lithium hydroxide, all the first year group bases, and then I gave 2 second year group bases also. So that is lithium hydroxide can give 1 OH minus ion. So its N factor, which is acidity, it's going to be 1. And then for sodium, potassium, rubidium, cesium, since all of them are first year group elements, so they are what do you say, that generally forms monoacidic bases. Okay, so since their acidity is 1, we can call them as monoacidic bases. Okay, and then next that is magnesium hydroxide and calcium hydroxide, they belong to second A group elements, and then their particular base acidity is going to be 2 because they are going to produce 2 OH minus ions in their dissociation. Okay, so hope it is clear. So I'll give few more examples on this N factor for bases. You please try to take the screenshot. Yeah, so here we have few more examples for bases and their acidity. So that is, since these are strontium and barium are second A group metals, so they are going to produce 2 OH minus ions in their dissociation, hence their N factor is going to be 2. And then whereas aluminium, that is AlOH taken thrice, so it is producing 3 OH minus ions, so N factor is 3. And then ferric hydroxide also, it is going to produce 3. And then zinc hydroxide is also going to give us 2 OH minus ions. If you go for ferrous hydroxide, so it is going to give us 2 OH minus ions, so its N factor is going to be 2. So this is about the bases and their acidity, and then I'll try to discuss about the N factor for salts also. So meanwhile you try to take the screenshot. So let's move on to N factor for salts. And now generally N factor for salts, we take it as total charge. So what is how to define this total charge? So charge multiplied by the stoichiometric coefficient of either cation or anion, we take it as the total charge for salts. So now if that is the case, if you come back to this examples, I have given a few examples. I'll give some more for your practice. And now if you take NaCl, okay, NaCl, that is Na plus and Cl minus in the dissociation. So if you can see, charge that is +1 and then stoichiometric coefficient is also 1. So we can take either cation or anion, that's up to us. Okay, so we should not take the sign, so we have to consider the number. So that is 1 into 1, so it is going to be 1 is the N factor for NaCl. And now K2SO4, potassium sulfate. So if you can see the dissociation of this, it is going to give us a 2K plus ions and then sulfate ion. If you can see the total charge, that is the charge multiplied by its stoichiometric coefficient, that is 1 into 2, so it is going to give us a 2. So I hope you understood. Next, if we move to aluminium chloride, Al plus 3 and then 3Cl minus. Even if we can directly take the cation or we can even take the anion. So if you see at the cation also, we are going to get the N factor is 3, and even if the anion also, that is -1, actually 1 into 3, so it is going to give us 3. And then aluminium sulfate, that is Al2SO4 taken thrice, if you can see, so it is upon the dissociation we are going to get 2 aluminium ions and then 3 sulfate ions. So what is the N factor for this particular salt? Please have a guess. So if you can see the total charge for this one, that is charge multiplied by its stoichiometric coefficient, it is going to be 6. Hope it is clear. And now please have a look about the zirconium phosphate. So try to understand. So if you can see the dissociation, we are going to get 3 Zr plus 4 and then 4 PO4 minus 3. So what is the N factor for this zirconium phosphate? So have a guess. I'm going to give you the answer also, so that N factor is going to be 12 because 4 into 3. Hope it is clear. So this is about the N factor for acids, bases and salts, and the concept of this N factor we are going to use in the case of calculating the normality. Hope it is clear. Hope you understand each and everything. So thank you so much for your patience, and then please, if you are new to the channel, please I request you to subscribe, and then please spread my channel to your friends and relatives, those who are even the students, those who are preparing for the IIT and NEET exams. Okay, so thank you so much. Hope all this information will help you a lot.